Thin layer chromatography, called TLC, is a technique used for analysis in organic chemistry. The first purpose is to check on the progress of a reaction to see if it is really forming product and if it has run to completion. The second purpose is to check on the purity of a sample, usually after you have cleaned up an impure mixture and want to know if you have been successful in separating the mixture. The basic steps for running a TLC are the same for both types of TLC analysis. A TLC plate is made from a very thin layer of a polar solid, usually silica gel, stuck onto a plastic or aluminum backing. The solid is called the stationary phase. A tiny drop of diluted sample, called the analyte, is applied to this plate near the bottom. More than one sample can be analyzed at the same time. The plate is placed in a container called the developing jar, which holds a few centimeters of a solvent or solvent mixture, called the eluent or mobile phase. The liquid can be made more or less polar, depending on which solvents you use. The eluent will climb up the TLC plate because of capillary action. The compound being analyzed will stick to the polar stationary phase if it is also polar and will only move a short way. The less polar the analyte, the less it holds on to the stationary phase. If it's not holding on tightly, it will be pulled up the plate by the motion of the mobile phase as it moves past the analyte, much as a boat will get pushed down the river by the current if it's not anchored to the shore. This is the equipment you will need to run your own TLC analysis. A lab book and pen, a TLC jar, also called the developing chamber, a TLC jar cover, a TLC plate, blotting paper, the liquid or liquids you have chosen as your mobile phase, also called the eluent, graduated cylinder to measure out the eluent, TLC spotting capillaries, a pencil, ruler, a UV lamp, standard laboratory safety equipment, gloves, lab coat, and goggles. Samples to be analyzed. This sample can be a solid or a liquid, but it must be diluted in a small amount of a very volatile solvent, such as acetone, dichloromethane, or ether. It is important that any solvent you use will evaporate as soon as the sample is spotted onto the TLC plate. Do not use high boiling solvents like water or toluene. The sample can also be taken directly from a reaction flask. Place the blotting paper in the TLC jar so that it wraps around the wall and touches the bottom of the jar. Measure out 12 to 15 milliliters of the eluent you want to use for the analysis into a graduated cylinder and then pour it into the TLC jar. Remember, it is easier to pour from a small container, so you might need to transfer the liquid into a beaker first. As an alternative, you may want to use a mixture of solvents. For example, 50% ethyl acetate and 50% hexane. In this example, 7 milliliters of each solvent would be a good choice. Be sure to measure out the solvents separately and combine them in the TLC jar. Make sure the total volume is between 12 and 15 milliliters. Cover the TLC jar and gently swirl to make sure the solvents get mixed and the blotting paper gets wet with the solvent. Allow the jar to sit with the cover on for at least 5 minutes. This would be a good time to go prepare your TLC plate for analysis. TLC is a very sensitive technique to find organic compounds, so you need to make sure you never touch the plate with your bare fingers or with dirty gloves. You could end up analyzing your own fingerprints. Placing the plastic side of the plate down, using a ruler and pencil, lightly draw a line across the bottom of the TLC plate, 1 to 2 centimeters above the bottom edge. Ink should not be used because it's an organic chemical and would move during the analysis just like the organic chemicals we are trying to analyze. This is called the starting line or origin line. Place light pencil marks evenly across the starting line, one for each compound you plan to analyze on this plate. These are referred to as lanes. Do not go too close to the edge, since this will cause problems with the analysis. How many marks should you make? To determine if a reaction is progressing, you should have at least 3 marks. The most important starting material alone, the reaction solution, and a co-spot, which is the place where you will put a spot of the starting material and a spot of the reaction on the same mark. To determine purity, you might have 2 to 4 spots, a sample of the original impure mixture for comparison, and a sample of the things you are testing for purity. If more than one, each gets its own mark, and a co-spot if there is room. It is good to put some label under each mark so that you know which is which. This might simply be A, B, and C. It is important to draw a sketch of the TLC plate in your lab book because the TLC plate will fall apart over time. Remember not to use pencil when writing in a lab book. Do not forget to write down which compound is going where in your lab book so you do not forget later. Now you need to apply samples onto the correct lanes on the plate. Take a TLC spotting capillary from the dispenser and dip one end into a diluted solution of the sample you want to analyze. Place the tube over the spot on the origin line where you want to place the sample and lightly touch the tip of the tube to the pencil mark you've already made. Touch quickly so that you only apply a small amount of sample. You can always come back to add more, but you can never take away compound if you add too much. Make sure to let the spot dry before you continue. Use this same technique to apply all of the desired compounds you want to analyze to their appropriate starting positions. Remember, if you are making a co-spot, you should let the first compound dry before applying any other compounds. To save yourself a lot of frustration, you should check to make sure that you have placed the right amount of compound onto the TLC plate before you start your analysis. You do this by placing the TLC plate under a UV light. It is important to make sure you do not look into the UV light as it can damage your eyes. If the UV lamp is in a stand, this should not be a problem. If there are 2 lights in your lamp, turn on the 254 nanometer or short wavelength light, which is the black button in this example. You should see the light come on by the effect it has on the TLC plate, which should glow in a green color. This is easier to see if you turn out the hood light. If your lamp does not have a stand, you will need to hold it over the TLC plate. Press the button to turn on the 254 nanometer light. Again, you will know the light is on by the effect it has on the TLC plate. If you have spotted your compounds correctly, you should see a small but very clear colored spot at each mark. If the spots are big, you have placed too much compound on the TLC plate. Check with your instructor, but you probably need to start over and create a new TLC plate. If the spots are very small, faint, or generally hard to see, there is not enough compound to analyze. Go back and apply more sample. Be sure you know which compound goes onto which spot. Be sure to turn off the lamp when you are finished. gotten the proper amount of compounds onto the TLC plate, you are ready to do the TLC analysis, which we call running the TLC. Take the TLC plate carefully, without touching the stationary phase, and place it into the TLC jar. Note that the starting line is considered the bottom of the plate and goes in first. The plate should be as flat on the bottom as you can make it and should not touch the blotting paper on the sides of the jar. Place the cover over the jar to prevent evaporation. It is very important that the liquid in the jar should be below the starting line when you begin. Over time, the eluent will climb up the TLC plate through capillary action. Watch it at all times and do not let the eluent reach the top of the plate. When the eluent has gotten near the top of the plate, remove it from the jar and immediately trace the front edge of the liquid using a pencil because it dries quickly. This is called the solvent front, and it must be seen in order to complete the analysis properly. If you forget to draw in this line or let the eluent run to the top of the plate, you must discard the TLC plate and start over. While still in the hood, wave the TLC plate gently back and forth to speed up the evaporation of the eluent. When dry, take the TLC plate to the UV light to help visualize the spots. Even compounds that have color are easier to see under the UV light. Circle any spots you see using a pencil. Now take this TLC back to your bench and finish drawing the outcome of this TLC analysis on the plate which you have started drawing in your lab book. Remember, you always use permanent ink when writing in the lab book. Use the ruler and determine the following distances. Measure the distance from the origin line to the solvent front in millimeters. This distance should be transferred into your lab book. This is the distance the eluent has moved. Next, you should measure the distance from the origin line to the center of every spot you have circled on the TLC plate. Use the center of the dot, not the front or back edge. Each of these distances should be written down in the lab book. Once you have all the distances recorded, it is time to calculate retention factors for each spot you see. The retention factor, or RF, is a measure of how far a compound moves compared to how far the eluent moves. Since compounds will move different distances depending on how polar or nonpolar the eluent is, you must calculate this ratio if you want to do a comparison of compounds. Any two spots with the same RF value have very similar polarities and may even be the same compound. In the example shown, there are 3 spots in the product lane, lane C, on the TLC. To calculate the RF of the least polar compound in this mixture, you would divide the distance it has traveled, 41 millimeters, by the distance the eluent traveled, 68 millimeters, to get an RF value of 0.60. RF should be calculated for each spot. When you are finished, you should be sure to dispose of the chemicals safely. A dry TLC plate is basically plastic and silica gel, which is just sand. This can be disposed of in the trash can. The TLC spotting capillaries should be disposed of in the broken glass container. Any extra eluents or leftover samples should be disposed of in the proper liquid waste bottles. Do not throw away the blotting paper. It can be dried out and reused for another analysis.